I'm excited to be joined by Mr. Jerry Melnick. He's the CEO and president of SIOS. How you doing, Jerry?
Very good, thanks, David.
Thanks for joining me today. So, I wanted to talk a lot about analytics and machine learning, but first, I bet a lot of people out there in the audience might not have heard of SIOS. So, why don't you first tell us what is SIOS and how do you help enterprises?
So SIOS is a software company. We develop and market and sell software throughout the world. We are a subsidiary, actually, of a Japanese company, publicly traded in Tokyo. We've been actually around for about 20 years doing this. We really help people protect and optimize their most important applications, particularly as they're moving their applications from physical to server to virtualization and cloud environments. And we're able to do that across the spectrum. So that's been our mission.
Okay, so helping enterprises deal with their performance, their capacity, their troubleshooting, and analyzing what's happening in their data center.
Yeah, I mean, certainly, if you look at us, historically, we were the first guys to do high availability clustering for Linux back in 1999. And that still is a big part of our business today on physical servers and virtual servers in the cloud, particularly in the cloud as people are adopting that. How do you keep those applications running? But about 3 or 4 years ago, we realized those customers moving to the cloud, moving to virtualization environments was like moving to the Wild West. All of a sudden, instead of just having 2 servers that are just deterministic and when they fail you can recover, you now have shared resources in virtual environments and the cloud that you have no clear understanding of what happened, what's happening, why is it not performing, how can I better optimize it, and why did it fail over? All those questions that you have to tease out, which have become enormously complex the bigger the environment gets.
Yeah, absolutely. Yeah, and so I know, enterprise admins, IT managers, like I used to be, we go looking for tools. What kind of tools can help me to solve these problems and troubleshoot and monitor our capacity for the long term, especially as we move, from one data center to the cloud, or we have multiple data centers maybe. So, I know there's a lot of tools out there in the performance and monitoring landscape. So why don't you tell us about your vision of the landscape and how SIOS fits in.
Right. Yeah, so as I mentioned, about 3 or 4 years ago, we realized we got to be able to tease out the really tough problems for these mission critical applications. So the ways that we're doing things today are just, dated back probably 20 years, in the 90s, where people were using, sort of hard-coded or maybe dynamic thresholds on a single CPU resource, or looking at CPU utilization, memory utilization, storage latency, I/O latency, and then getting tools to deliver them alerts. And then they're doing the work, looking at the alerts, looking at logs, trying to understand in this flood of data what happened, and just being overwhelmed. There's been some advancement, as I mentioned, people have done some dynamic adjustment of those alerts so that maybe they're a little more intelligent than they were before, but they're still not imparting a lot of data. The human being is left to really parse that out and figure it all out. And when we talk about the hundreds, if not thousands of VMs some of these customers see, and the hundreds, if not hosts, or if it's in a big cloud, it's not humanly possible to do this anymore. So the idea really was, how do we help them out by getting a machine to figure this out? Because with the evolution of data science, particularly in the last 3 or 4 years, has been enormous strides in being able to try to tease out really important information out of that data, out of raw data sets. And so that's what we did was we embarked on a mission 3 or 4 years ago, really to look at this. So what can we do using data science rather than the old legacy computer science to help IT figure things out, understand what's happened, how to make it better, and also look ahead, because of course when you start to use these kinds of statistical technologies, you have the opportunity to forecast the problem, so you can predict the call is going to come before it's going to call, or that you can avoid the problem so you're not going to have to be in on Saturday.
Yeah,
right?
Absolutely. I mean, that's what enterprises really want. They want to prevent problems before they happen, so that there's never any outages or there's never any slow performance for their applications. So that I find that idea really attractive. Or minimally, at least tell me the exact source of the problem, the root cause. I mean, I remember having problems on the network and in the data center, and the logging server runs out of disk space because there's so many alerts, and in my email inbox I have 1,000 new email messages. I mean, that doesn't really help me. I need to know where the problem is,
Right.
and make a decision about it fast. So you're talking about using machine learning essentially to find these problems and prevent them. Is that right?
That's right. I mean, what we've really done is focus on infrastructure, real-time infrastructure metrics, not alerts, not thresholds. And you have to it's kind of hard when you talk to people about this because you have to kind of forget what you know and just think about the raw data. Say the raw data that comes out of a vCenter, for instance. These are CPU metrics of utilization, memory metrics, all those sorts of things. And then we think about sort of how the different pieces of the infrastructure are related to each other. And from that, we study their patterns of behavior over time. So we develop a learning set of patterns of complex behavior of all these objects over time and the metrics. So it's what's called a multidimensional analysis. And we look at hour and day, day of week, week and month, month and year, so that we know that a backup's run on Thursday, that the machines are the infrastructure is going to look like this. It has a pattern, a statistical pattern. So if there's a change, then we can see that. And we can basically produce that information and tell you a lot about it. Since it's multiple dimensions, multiple objects, and behavior patterns, we say all these things happen at the same time. And the reason why that's important is if you think about the technology of today that people are mostly employing, a single dimension of a metric, like a CPU utilization of one object, it's a piece of data, and the likelihood of it having meaning in these shared environments is unclear. But if you can find a pattern which is much more complex about a group of objects and multiple metrics of those objects, then the meaning of that is significantly higher. And that translates to no alerts, no fewer alerts. You're only getting delivered something which is definitely out of band. So it's meaningful. The machine found it. It was hands-off. You had to do nothing to do it. I mean, this is literally load it, go, walk away, come back. And we're going to deliver that very small nugget that you're looking for with all the interconnections and what happened at the time, and tell you who did it, who's the victim, who's the villains, and help you figure out what to do about it.
So it's almost like using data science and analyzing what's really going on in the data center and creating a software that's smarter than we are, if you will, to help us solve these problems and prevent these problems. Is that true?
That's very true. I mean, if you think about it, we've kind of built this box, which has encapsulated a tremendous amount of sophisticated data science, which really has inputs of infrastructure metrics. And it spits out from that over time as it learns the behavior anomalies, which basically allows you to be hands-free in trying to understand what's happening. Now, you might say, well, that's great. So you can find anomalies in the infrastructure. Tell me, which one of the objects was causing the problem, and that's all good, and it's automatic, and I don't have to do anything, which is something I can't get to today, obviously. And then you might ask, so what about the application? And the way we perceive that is that, if we solve the problem in the infrastructure, finding those anomalies, then we've eliminated an enormous amount of work that you've been doing already. I mean, you're staring at screens and monitor screens of CPU memory, storage, graphs, and trend lines, and trying to understand what that all means. And we said, that's something we can manage now. We've taken that away, and you can spend your time instead trying to figure out what's important to my IT service delivery. Application performance, maybe it's speed of my market basket, maybe it's the cost per transaction, maybe I want to make sure that when I put a patch in the system, I've tracked that and follow it. And we can take that information to signals from other tools and correlate that to what we find in our machine learning technology in terms of the artifacts and whatnot that's going on. So you can answer the question, how did the infrastructure impact my application performance, and what changed? Because if nothing changed, you probably would keep running just the way it was, right?
Right.
And that's sort of a central piece, and how we feel this kind of technology fits in so significantly different. And I'll mention one other thing is that it's important to talk about, you mentioned data science, and it's important, there has been an enormous amount of, I'd say, marketing fuzz around AI and machine learning. And we've been in this for a while. We have experts who have been deeply in it for 20 years who have worked on this. And we've taken and done the hard thing. This is not just kind of slapping some extra sauce on top of something that existed already. It's really looking at it from a completely different angle and saying this is the important problem to solve and where people have to go in the future. This is where it's going.
Very nice, very nice. So for those who might be thinking, hey, this sounds really appealing, having this super smart software help me to manage and predict problems, in my data center. Why don't you tell us for a moment, what is this, the software, the product, and basically how does it work? How would someone use it?
Yeah, so for instance, the VMware environment, we are an OVA that you download.
Okay.
About a 15-minute install. You give us some credentials in order to get the vCenter data out, and then you walk away.
Okay.
You come back in 7 days. We've put a best practices learning set programmed in there, so you'll get some information back relative to best practices, but those will be replaced over the period of a week, 2 weeks, and a month, and the data will get better over time. So we'll learn those patterns for your environment. So it's really that simple. There's no setting thresholds. There's no configuration. If something changes, you don't have to worry about it. We're going to learn about it. It's completely what's called completely unsupervised learning in that regard, so that as you add new workloads, you'll find out about it the first time, but you won't find out about it again if you don't want to do anything about it. And we'll reveal everything we know about it to you and help you figure out what to do about it. So we are adding and have already added what we'd call some unsupervised capabilities. So you'd say to me, hey, so that's nice the machine find it, but I knew all about that. And I don't ever want to hear about it again. And that's where a human imparts knowledge to the machine and tells it that this piece of information, if you see those patterns or some patterns are statistically significantly alike, don't bother. Or you might say, this is interesting, and like a piece of paper, put it over here, and if it happens again, or if it happens for some time frame or for a number of times, I'd like to hear about it. So now you have some human supervision.
Very nice. And then what do you see in the future, of machine learning and analytics, in the data center, for SIOS IQ and other tools?
Well, if you look at what today, we're a packaged application. We have a UI with really brilliant, visualizations that help you see the information when we find it and whatnot. And it was really built to do that because we felt as though we were kind of early to the machine learning market, and we didn't, the notion of what do you do with the analytics was unclear. So we built what we'd call an intelligent application that sits in the VMware environment. At the same time, the market over this period of time has evolved, and the maturity of the IT organizations, particularly in the larger organizations, has evolved as well. And they've kind of figured out that this notion of having tools for silos of network storage, etc., is problematic because you're left to correlate the things between that. So they've taken more of a data orientation. They've adopted data platforms like Splunk or Elastic and whatnot, and they're pouring all that information into these data platforms. And now, and if you look at the early adoption, people have been doing that with log analytics, as you mentioned, and they've slowly, but they're very reactive, kind of small scale. But some of the largest organizations are putting everything in those data platforms, and now they're really struggling with, so how do I analyze that data? And we are built to analyze data across those silos, and the data is now on another platform. So we're a perfect analytical tool for them to be able to plug into that data platform, read the infrastructure metrics, and then take data where they want to take signals that come out of other sources like application sources, as I mentioned earlier, and correlate it to it. So we kind of help fill out a very important piece of sort of that analytics workflow, so what I call the analytics supply chain. So rather than building lots of different dashboards for everything you come across, you think more in a structured flow of here's the problem I want to solve, and here's the metrics I want to capture about my IT service delivery. Here's an analytical tool, SIOS IQ, that can find anomalies in my infrastructure, and I can marry those two things because SIOS IQ solved the problem of analytics for the infrastructure information.
Very nice. So today you interface with Splunk?
We do on the signaling mechanism, and we'll be ingesting shortly from Splunk itself the infrastructure metrics. But we ingest today from VMware, and we're moving along to other ingestion platforms such as cloud, etc.
Very nice. Data is just continuing to grow and grow and grow. It never stops. And so companies, I foresee them needing more and more smart tools like SIOS IQ to help them make smart decisions and analyze this data at a higher level and help them prevent problems before they happen, and make the right choices for the data center. So
yeah, I mean, if you think about other types of businesses, for years we've been building data warehouses, and they comprise of multiple silos in the business, and we learned to put them together in the 90s, and we've learned to optimize how we analyze those and deliver value. And IT has been sort of the poor child in the whole, whereas they've delivered all those services, but they never took IT data in the same way and crossed the silos and really tried to analyze it and apply. And in fact, IT has a better chance of succeeding than because the data is actually much cleaner, right?
Right.
It's coming out of machines. We can apply machines to it. And so certainly the future is bright for analytics in this environment, and intelligent analytics.
Excellent. Well, thanks so much for talking to us today about your innovative data analytics solution. I appreciate your time.
Thank you very much for having me.
For more information, visit us.sios.com, and of course visit the SIOS booth at VMworld.